Let's look at the solutions of modern maths bites. 5 addressed letters and 5 correspondingly addressed envelopes are kept on a table. One letter is put into each envelope, but is done randomly without paying any heed to the addresses. In how many distinct ways can the letters be put in envelopes such that exactly 2 letters are put in the wrong envelope? Okay. So let's say we had envelope 1, envelope 2, envelope 3, envelope 4, and envelope 5. First, select the 2 envelopes in which the wrong letters are going. You can do that in 5C 2 ways. And let's say those 2 envelopes selected are E1 and E4. These are the 2 envelopes in which wrong letters are going, which means letter 2, letter 3, and letter 5 go in the right envelope. And now E1 is supposed to get the wrong one. It cannot get letter 1. So it will necessarily get letter 4, and E4 will necessarily get letter 1. There is just one way of arranging these. Therefore, your answer is limited to 5C2 or option A in this case. Next question. In how many different ways can 4 identical objects be distributed among 8 people such that any person can receive any number of objects? All 4 objects need to be distributed. Okay, let those 8 people be A, B, C, D, E, F, G, and H. They are supposed to get 4 articles, 4 identical objects. Now, the way to distribute this with whole number solution sets is given by n plus r minus 1 c r minus 1, which will be equal to 11c7. Now 11c7 is not present within the options, so but we have 11c4. We know ncr is equal to nc n minus r. So 11c7 will be equal to 11c4 also. So option D will be the answer. Next question. What is the probability that the number turned when a dice is rolled is not composite? When a dice is turned, you can get these 6 outcomes. If we want not composite, this cannot come, rest 4 can come. The answer is 4 by 6 or 2 by 3. So option C. 4 dice are rolled. Find the number of distinct outcomes possible such that the sum of the 4 numbers turned on the dice is 11. Okay. Let's see. We have 4 dice. A plus B plus C plus D is equal to 11. But remember, because these are dice, each of them will definitely have 1 present on each of them. So let's give out 1 to each of them. The summation now reduces to 7. So the total number of ways in which this can be accomplished is 10C3. But within this, there will also be these cases. 6100, 6100. This will be rearranged in 4 factorial by 2 factorial ways. This will be done in 4 factorial by 2 factorial ways. And another way would be 7000. This one will be done in 4 factorial by 3 factorial ways. So how many cases are we getting here? 12 cases, which are unacceptable. Because see, if it was 6100, 1 was already given to them. 1111 was already given to them. If you give 6 to A now, it will have 7 on top of it, and 7 is unacceptable. You cannot have 7 coming out upon rolling a die. Similarly, 7000 is also unacceptable because that effectively leads to one die having 8 being available. And then we do this 4 factorial by 2 factorial just to get the total count. It is not necessary that A ends up with a number greater than 6. It could also be B, it could also be C, it could also be D. Same thing here. So we get 4 cases from here. So the actual count will turn out to be 10C3 minus 16 as the final answer. 10C3 is 10 into 9 into 8 by 6. Cancel, 12. 120 minus 16 will be equal to 104. So answer is option C. Last question. A satellite system consists of 4 components and the system functions correctly if at least 3 of the components function correctly. Each of the components functioning is independent of others and has a 0.75 probability of functioning correctly. Find the probability that the satellite system will function correctly. So the cases when the satellite system will function correctly is when all 4 are working, when 3 is working and 1 is defective. All 4 are working will be given by 3 by 4 is probability for 1. All 4 of them given by this. 3 working and 1 is defective is which 3 are working? 4C3 you select in that. The 3 that are working, their probability 3 by 4 is per 3 into 1 by 4 probability of the defective one. So from here we get 81 by 256. From here we get 108 by 256. If we add them together, we will get 189 by 256 or option D. And that is the answer to this question. That will be all for this bites. Hopefully you learned something. That will be all. Okay, bye.